I am recording this. Hopefully you guys are copying it down or finishing up copying it down. We are moving on to section 8.3 today, but I wanted to do a quick review of section 8.1 to 8.2, which was on polynomials. And 8.1 especially was heavy on vocabulary. So we have this polynomial right here, and we need to answer all these vocab questions. So number one, state the coefficient of x. Okay, so what we need to remember or understand, the word coefficient is simply the number in front of your variable. Okay, so state the coefficient, state the number that's in front of x. So what number's in front of x? Well, this is an x squared, that's an x to the third. Here's x, what number's in front of it? -7. So -7 is the coefficient of x. Okay, I hope we all understand that. I hope we all see that. The word coefficient simply means the number that's in front of your variable. Okay, so with that said, if the coefficient means the number in front of the variable, the leading coefficient would be the number that's out in the front of your standard form polynomial, right? It needs to be in order. Okay, so a lot of people say, oh, the leading coefficient is 2. That would be wrong. The leading coefficient's not 2. The leading coefficient's what? Anybody? -1, that's right, because you need to put it in order with your highest exponent term first. So technically, this guy should belong over here in the front, okay? So then the number that's in front would be a -1. So the leading coefficient would be -1. So I skipped from number 1 to number 3 because they both had the word coefficient. Coefficient is simply the number in front of your variable. The coefficient of x is -7. That's the number in front of x. The leading coefficient is, if this whole thing were in order from highest exponent down to smallest, then your coefficient will be the -1, because that would be out here in the front. Okay, constant was another vocab word. Constant, that's simply the number without a variable. So what's the constant of this guy? 5. Okay, constant is 5, because you could see that 5 is right there without the x. You see, constant means that it never changes, and +5 will never change. It'll always be adding 5. If you had a 5x, then that'd be a different story. If x is 1, it stays 5, but if x is 2, it becomes 10. Or if x is -3, it becomes -15. So if you had a variable on it, it wouldn't be constant. It would vary depending on the x value. State the degree, that's another vocab word. Degree is the highest exponent that you see, and what's the highest exponent you see? Power of 3, so the degree is 3. Rewrite in standard form, that would be writing this in order from highest exponent term down to the lowest, down to the constant at the very end. So first you should have the -x to the third. Then you should have the 2x squared, and we're going to put plus 2x squared. And then after that, we should have the regular 7x minus 7x. And at the very end, you want your constant, the +5, okay? Once again, highest exponent term down to the lowest, down to the constant. This is what we call standard form, okay? And whenever you have a polynomial in standard form, it's really easy to classify. I hope we remember on our notes, we had these notes, which had all those vocab words, and we had the classification of polynomials. The first name is based on the degree, the highest exponent. So if you have the highest power of 4, that's quartic. Highest power of 3, cubic. Highest power of 2, quadratic. Highest power of 1, linear. You don't even really have to worry about power of 0. That would make it a regular number. So that'd be a constant. Anyway, if you have 4 terms, that's a polynomial. 3 terms, trinomial. 2 terms, binomial. 1 term, monomial. So with that knowledge, we should be able to see this highest power of 3 and classify that as cubic. And last name, how many terms? 1, that would be a monomial. 2, binomial. 3, trinomial. 4 or more, that's many, and many means poly, so polynomial. So cubic polynomial is the first and last name of that variable expression right there, that polynomial. Cubic polynomial. Bless you. Let's move on. In addition to all that vocabulary on yesterday's quiz, we also had adding polynomials and subtracting polynomials, and also distributed property, and also some solving equations, but I'm not going to go over the solving equations ones. I saw a lot of people get confused with these, and they're so easy, right? We should not get confused with them. So, for example, if I have any parentheses at any time, I should always check and see if there's a number out here that I could distribute into each term. So there is no number to distribute, so technically I don't have to worry about the parentheses, okay? So I could technically scratch them out. Do I have anything to distribute over here? Well, there's a plus sign. But if I distribute a plus sign, like if I wanted to give it a number, it would be a positive 1. But if I distribute positive 1, like 1 times negative x to the third is going to stay the same, right? So when you're adding two polynomials, you could just ignore the parentheses and jump right into combining like terms, okay? Now, if you were subtracting, then for sure you need to distribute, which would cause a change in all of the signs. This would become a positive 6. This would become a positive x to the third, a negative 7x, and a minus 4x squared. When you have a minus, you have to change all the signs. When you have a plus, if you distribute it, it doesn't change anything. So anyways, when there's a plus sign, you could just start combining like terms. And since you want your answer in standard form, let's start with our highest exponent terms. Let's go with negative x to the third combined with this negative x to the third. So we're not multiplying, we are combining. You owe one of these x to the thirds. You owe another one of those x to the thirds. How much do you owe? You owe 2 of those x to the thirds. Again, exponents do not change. Why? Because exponents come from multiplication. X times x is x squared. Exponents are only going to change when you're multiplying the same base. That's when exponents change. Anyway, right here, you owe 1, you owe another, you owe 2 of those x to the thirds. Then we move on to the x squares. Oh, we have a 2x squared that we're going to combine with a 2x squared. What do I end up with there? Positive 2 and positive 2, positive 4, right? Positive 4 of those x squares. And then we move on to our regular x's. We have a minus 7x and a positive 7x. What happens there? They cancel out. They disappear. They're gone. I don't have to put any x's right here. And then finally, our number 5 with our number negative 4. What is 5 minus 4? Positive 1. So you can put plus 1 right there. So this is really just adding and subtracting, right? If you have a plus sign between your parentheses, you could just ignore the parentheses and start combining like terms. But if you have a minus sign, you have to distribute the minus sign. That causes all the signs to change. Okay, so this minus sign is going to make that a positive 6. It's going to make that a positive x to the third. It's going to make that a negative 7x. It's going to make that a negative 4x squared. Is there anything to distribute out here in the front? No. So you don't have to worry about the parentheses. I mean, technically, you could say, yeah, there's an invisible 1, and 1 times 5x squared is still 5x squared. It's not going to change anything. So just rewrite it without the parentheses. And look at all these terms. 1, 2, 3, 4, 5, 6, 7, 8. We need to combine the terms that are alike. So we're going to start with our highest exponent term, the negative x to the third, with the positive x to the third. What happens? They disappear. They cancel out. And then you move on to your x squared terms. You have a 5x squared with a minus 4x squared. What do I get? I get 1x squared. And you don't even have to actually write the 1. If you want to, go ahead. And then you move on to your regular x's. You owe 3 x's and you owe 7 x's. How many do you owe? You owe 10 of those x's. And last but not least, the minus 6 with the plus 6. What happens there? They cancel out, so you don't even need to put any constant. There is no constant, okay? So those are the 2 answers. Here's the answer for adding the polynomials up there, and here's the answer for subtracting the polynomials. The big difference is that if you have a minus sign, you have to distribute before combining, because that's going to change all the signs. But if you distributed a plus sign, it doesn't change anything, so you could just start combining right from the start. Another detail I want to point out is, look at the work that I did. When I combine x to the thirds and x to the thirds, I use circles. And then when I combined x squares with x squares, I didn't circle anymore. I used a different type of symbol, like a squiggly underline. And then when I went for the x's, I underlined, oh wait, I'm sorry, I underlined and I underlined. So I use different types of symbols. That way, if I do need to look at my work, it's easy. Oh, I combine these two, I combine these two, and I combine these two, all right? As a review, what would this be classified as? First name would be what? Cubic. Last name? 1, 2, 3. Trinomial. Cubic trinomial. How about this guy? Quadratic. How many terms? 2 terms. What would that be? Binomial. Okay. In addition to that, we had some distributed property and combining like terms, but nowhere near as challenging as this guy. Right here, if you understand this one, you'll understand any distributed property problem, which is great because it's going to lead right into today's lesson. Check it out. I'm going to take this monomial. It's technically a quadratic monomial, and I'm going to distribute it into the cubic polynomial, right? So I like to circle and draw arrows. 3x squared times 2x to the third. How does this work? Well, you multiply the coefficient with the coefficient, right? So when I go 3 times 2, what do I get? 6. And now when I go x squared times x to the third, what do I get? X to the fifth. Because rule 1 of exponents says when you multiply with the same base, 2 terms with the same base, you add the exponents, giving you 5. Okay? So it's kind of like doing 2 math problems in one. You multiply the coefficients, get the answer. Multiply your variables by adding them and get your answer. Okay? So how about if I distribute it over here? 3x squared times, now this guy right here is a negative 1x squared. So there's technically like an invisible 1 right there. So that's a negative 1. So when I multiply the coefficient 3 times the coefficient negative 1, what do I get? Negative 3. And when I multiply x squared times x squared, what do I get? X to the fourth. Yeah, you add 2 plus 2 and you get 4. Now let's distribute it over here. 3x squared times 5x. Well, we're going to begin with the coefficient 3 times the coefficient positive 5. What's positive 3 times positive 5? Positive 15. Okay, and then how about x squared times x? X squared times 1 more x. What do we get? X to the third. Perfect. And last but not least, let's distribute the 3x squared times the minus 7. Well, start with the coefficient. 3 times minus 7. What's 3 times minus 7? Minus 21, that's right. And then how about the x squared times, oh, there's no more x's, so I could just bring down that x squared. And there's my final answer, okay? So why did I start class with a review from yesterday or from the previous 2 sections? Because a lot of us did horrible on that quiz yesterday from section 8.1 and 8.2. And maybe now you understand the vocabulary a little better. Maybe now you understand how to distribute that minus sign, then combine like terms. Maybe now you know how to distribute. And there was also solving equations. So I highly recommend, if you understand it better now, please go back and do that practice quiz. Do it over again. Write down each question in your notebook. Watch the videos and write down those steps in your notebook. That way you could come and retake it after school, right? We're running out of time here, guys. Next week is the midterm exam, so please bring up your grade as quickly as possible. Let's jump into the lesson, but I want to do that on a different video.